Hello, welcome back to today's video. So today is a second video following the part one of Go fundamentals, and this is going to be part two where we cover the conditional statements, we cover pointers, JSON handling, and we finally do our small project where we actually consumed an API. If you look at this, we have the fetch contacts from an API, and then we have also the create contact to the API. So we look at actually how to deal with external APIs, where we have like doing post request fetches, and we used the mocha.io to test our API. So this was really also having a lot of concepts that we looked at. More especially, we looked at pointers, JSON handling, and all others that are packed. So let's just dive in and get started. Hello everyone, welcome to today's video. So in today's video, we are continuing from our previous video where we looked at Go fundamentals, and we covered a lot of concepts in that video. We looked at packages, we looked at fundamentals and everything. So in today's video, we are continuing looking at the basics. And if you haven't subscribed, please go ahead and subscribe, and thank you so much for your support. So I hope that this content is so much helpful to you in your career. So in today's video, we're going to cover these concepts, and this might be the one of the last videos for fundamentals. And the next ones, we're going to be looking at projects, different projects, as we move on. Okay, yeah, so I'm just going to go here, start with conditional statements. So we did not look at conditional statements, so I want us to look at the conditional statements. So let's say conditional statement, we have the if statement and the switch statement, but I'm just going to cover only the if statements, which are the ones you're going to be using most of the times. So let's say we have our variable like age, and we can just have age is equal to maybe 25. Okay, and we all know we can just come here and we do an if statement, and we say, for example, if age is greater than 18, maybe here we can just say print that maybe you are allowed to vote. You are allowed to vote. Something like this. You can also do else if. So you can say, for example, else if age is greater than 10, and then you just say, for example, that we can just say that print that print function, print here, and you can just say you are a teenager, and then you can just say else, and then you just say fmt dot print line. Maybe we say here you are too young. So we can do if else statements just like this, and if you just go ahead and right now run go run main dot go, just like this, go run main dot go. So if I just go ahead and run this, you can see you are allowed to vote. If I change this to 5 and we run again, so this is just like a normal if statement. This is a normal if statement like in JavaScript. The only difference is that we don't need to put brackets on the condition. So one more thing here is that what is very interesting is that we can actually define, we can write a shorthand of this. So let's say I don't want to write, for example, I want to make an if statement for something. I can just do also like you can define, and you can say, for example, if, and then you can just say, for example, that price is equal like 100. So you can just go ahead and, for example, and define. So this, in the if statement, you can just go ahead and first create a variable, and then after you can just now compare the variable, and you say, and if price is greater than 200, and then you can just write an if statement here, and you say maybe this product is very expensive, something like this. So this is also a shorthand. This is a shorthand for if statements. You're going to find something like this in most occasions. Like we do define a variable, and after defining a variable, we can now go ahead and do an if statement on this variable. This is a very common pattern that you're going to find in most of the project you're going to be doing. Now, since we are on the if statement, let's look at error handling. This comes in handy because in most cases we use if statement to check for errors. Okay, so we can just go ahead and create a function here. Let's say create a func, and it's going to be like you're going to see have this function for maybe divide. Okay, and this function for divide, let's say it takes in two numbers like a and b. Okay, so we're just going to be having like situations whereby you have like a over b, so that we just want, and b is going to be a float. And here the output, most of the times in these functions, you're going to see that two things that can happen. In most of the functions, actually just like that. If you're having any of these functions, you're going to find that actually, let's just say for now, since the divide is a very common example, I'm just going to use the bath, sorry, like calc edge, right? Calc edge, and let's say this takes in the bath year only, bath year, which is going to be actually an int. And then here you can just imagine the situation whereby a person puts in the birth year equaling the current year. So let's say the current year is 2025, and someone has 2025 minus 2025. Let's say we want to make sure that this person doesn't enter this, or we want to consider this as an error, okay? Because they want to say that the birth year cannot be equal the current year. So in this, we can just go ahead and do an if statement. For example, we say if, we can say if the birth year, so we can say if the birth year is equal to 2025, okay, and then we can now go ahead and return an error. So if a function is going to return a result and also an error, we can just come here and we say this is going to return two things. It's going to return an integer, also error. So we have this type of error that we always have. So we can just come here and we say if birth year is equal to 2025, then we can just come and say that first we can return, okay, so in terms of the integer we say 0, comma, and then we can also return a new error. So we can just say, for example, error. So you can just say errors dot new like this, and then you can just say, for example, that birth year cannot be the same as current year, just like this. Okay, and then if you pass this, we can just come down and say here, and we say now return. Okay, we can return 2025 minus the birth year, comma, and then we just say near, just like this. So we are returning two things. Either we are returning an integer or we are returning an error. So in this case, we handle the error, and then we return the error if it happens, and then we return also the result. And in this state, when everything is okay, we return near. And we are going to say this is a very much common pattern for all Golang functions. There is always calculating possibility of errors, because in Golang they have decided to handle errors gracefully. So in every example or every function, there must be a bit of handling an error. So if you just go back into the main function, you can now just say, for example, where we have our age, okay, so you can just say, come here, that I can just do this. So we, of course, you can just say, for example, var new age, okay, is equal to calc age, and you can pass in, for example, 1990, right? Now, if you do this, you're going to say, like here, the multi-value calc age, okay, here we just having only one variable, and you say that this returns to values. So this is why we need to capture the error. So you just need to say, for example, it's going to return my new age. So you can say my new age, comma, error, just like this. And this, of course, has to be defining. So you find that you have something like this. You can get the error, or you can just get the age. So we can first check for the error, and we say if error is not equal to near, okay, that means there is an error. Then we just go ahead and we console. So you can say fmt.print, for example, the error. So you can just go ahead and say, for example, encountered error, and then we do something like this, and then we put the error, and then here we go ahead and actually return. We don't want just to, if we get an error, to continue. Then if we just go here, then we actually have the division. So you can say here fmt.print line my new age, just like this. Okay, so you can say if statements help us so much in error handling. Okay, just going to be having this kind of syntax. If statements are going to be used more and more when you're like handling functions. So if I just go ahead and run this, so you can just say, like, we have 35 here. So if I just come here and I put 2025, for example, so you can see here that we have an error. Encountered error, birth year cannot be the same as the current year. Okay, yeah, so that's the error handling. Hoping that that is very easy to grasp. So if you just go here, we have seen the conditional statements. What I've seen about the shorthand and also error handling. So let's go to pointers. Okay, let's go to pointers. So I'm just going to go ahead and clear everything here, I'm just going to go ahead and create a new file, or I'm just going to add everything here. So I'm just going to copy. In fact, let's duplicate this, and in this I'm just going to go ahead and rename this to statements like this, and you can just go ahead and change this package. I don't know, do I need to change that? But you can just go ahead and change let me change this one to maybe, you can leave the package, but you can change this function to maybe statements. Okay, I change this to statements like this. Okay, I don't know why are we still having this calc edge. So just go in the main and let's remove everything. So we can just remove this function, for example, and even everything in the main like this. Okay, so let's just look at the pointers. So before we just have to first understand what are the pointers, and why do we need pointers, and what are the use cases for pointers. And pointers is one of the concepts that are very not easy to understand in Golang, from my opinion, and I'm just going to really try to explain them so that you understand them carefully. So I want you to see this as the maybe, let me just first grab this. So I just have, let's say we have our computer, or we have our server here, and in this server, every time we create a variable, okay, every time you create a new variable and you say var x is equal to 25, that value is assigned a memory, okay, or it is assigned a space in memory to hold or to store that value. So in that memory, we have two things. We have the address where that variable is stored, so that is the memory address, and then we have the value of this value we have here. Okay, so what is a pointer? A pointer is a variable that stores the address of another variable. That is by definition of a pointer. You can just go here and we can just go ahead and look for where we have like the pointers. Not sure where we can find them up here. Okay, so we have the pointers here. Okay, and I want to show you the definition here of a pointer. So you can see a pointer is a variable that stores the memory address of another variable. As simple as that. It is a variable that stores the memory address of another variable. So we have, as I said, we have two things, the address and we have the value. Now this introduces to us two signs or two operators. We have this asterisk, I think it's called asterisk. You can confirm that. But this star here, normally is referred to asterisk, and this one is referred to ampersand. And this ampersand, so in the pointers, wherever we see the and, this refers to the address. And wherever we see the asterisk, refers to a value. And let's give an example. And let's first wait, why do we actually need this? Okay, so to understand this, we can actually create an example. So let's just create an example here, and we have, for example, age. So I'm just going to create age, and we can just like do age equal to 20. Okay, So let's say we create a function that is going to help us modify 20, because we know if we do something like age equaling 40, at this point age has changed. Okay, this age has changed to 40. We all know that. But surprisingly, if we just do a function here outside, let's say function, and we just call it modify age, okay, and this would take in age, okay, and this is int, and then we'll just come here and we say actually like age, okay, and we give it a new value which is like 100, and then we call this modify age. So if we just call modify age here and we pass in age, okay, so you would understand that if I go here and I say, for example, fmt dot print, and I just want to print age. So let's just think about this situation. We have the age here. We pass this age to modify age function, which actually changes this age to 100. Okay, and then down here we are printing age. I expect to see actually 100. Okay, because age was modified here, and here we might just be seeing 100. So if I just go ahead and run main.go, go run main.go like this. So if you just go down here, you see that we actually have 20. So the modification did not happen. And why is that? So we go back to what happens if you try to modify a value on its own in a function. So what happens, Golang or Go, what does behind the scene, is going to actually create a new copy, okay? Is going to create a new copy of this value, okay? It's going to create a new copy of this value. So when you just say, when you come to this and you say age is equal to 100, what basically they make a copy of this age here. So basically they have created another new variable and then they change that copy. So it's like the way you see in photocopying. So you have like a copy, you have the original copy here. So this is the original copy. And then you go, you photocopy another one, and then you modify this one. So you just go and modify this one. And this is a photocopy, right? So when you change this one and you go back to the original one, this is unattached. This is not modified. This is what's happening right now. When you pass in age equal 100, what Go does that it creates a new copy of age and then modifies that. And in most of cases, we don't want that. We want to affect the original value, right? We want to affect the original value. So that's where the pointers come in. So the pointers make sure that instead we don't make this copy. Instead, we actually modify the original value. So let's say we have the this 100. So instead of modify age, how would we actually do it? So I'm just first of all go ahead and comment this. So let's create a pointer. So a pointer would be another variable, right? It is a variable that stores the memory address of another variable. So what we need to be able to always change this, we need its memory address. So to get its memory address, I can just come out and I just define another. So you can just come and I say, for example, maybe let's just call this variable to be my pointer variable. So you can just come with this one and call it like my pointer variable, like this. Okay, and this to point to the address, we just come and say, I think I can just do this. I can just come and say that you just simply say and age, just like this. So remember, the and is actually points to the address. Okay, in the pointers, wherever you see the and, it points to the address. let's go ahead and actually print out my pointer variable like this. So if I just go ahead and run the go run, you will see that actually we get back the address. So this is actually the memory address of this value. So you said wherever we say and, we have access to the address, the memory address. So this is the memory address of age. So since now we know its address, we can actually change it every time. Instead of just bringing new copies, we can change it every time. So how does a pointer actually be able to change the value of this? Now to change it, you just come here and you say star, because this actually gets access to the value. And then you say my pointer variable, and then we give it another new value, 100. Remember, if you go ahead and console.log the star, okay, so we can actually just say before doing this, let me just say instead of console.log just my variable, I'm just going to go ahead and say star here like this. And if I just go ahead and run main.go like this, you can see that it actually prints out 20, which is the original value. Okay, so as we said, the star gives you the value and the and gives you access to the memory address. So if I want to change the value of age through my pointer variable, I'm just going to come and do this. I say star my pointer variable, which actually has access to 20, or the actual value of age. Now we modify this value to 100. So if I now go ahead and print out age, okay, not even my pointer, I just want to go ahead and print out age like this. If we go back and run this, is that we actually get 100 on the console, which means that the age was actually being modified by this pointer variable. So you can now get to know what is the purpose of a pointer. So a pointer is a variable that has the memory address, and this allows us in Golang to modify the values of an original variable. So in this case of our modify age function, we can just go here instead now of passing in here. The only thing we need to be able to modify age is so that we actually need to pass in the address. Okay, you need to pass in this address. Okay, you need to pass in this address, and when we pass in the address of age, we'll be able to actually manipulate that. So we pass in the address in the modify. We need to go inside this. Instead of just like now receiving just age, we are actually receiving an int which points to, okay, so this is how we do it. We actually get, let's say we are getting age, and this age we are getting is, so this is the pointer. When you say int like this, age, and you say it is going to be star int, it means that whatever you are passing in, you are passing in a pointer. Okay, we are actually referencing to a pointer. And then here you say cannot use 100, and I typed int constant, as int value is an assignment. So we can just come here. First of all, we are passing in this. Okay, let me first see if we just do age plus plus. Okay, let's first see this. Cannot use and I typed int constant. Okay, so we can just come here and do we need to give the type? Because this, if you look at the type of this, so the type of this, you can see it is star int, meaning that it is pointing, or the type of our pointer variable. So this is how we always define the type of a pointer variable. We add the star to indicate that this is actually a pointer. So I just want to know why right now we are not allowed to do this. Okay. Modify, and here we are not allowed. Let me just go ahead and look at my example I have here. It seems to be not working. Okay, so let's say we have modify with pointer. So I have my x equal to okay, this is the function. Oh, so we actually need not to change the age. If you remember, we actually need to change the address. So because you cannot just have now access to age, because what we are passing in here, we are passing in the address. If you look at this, we pass in the address, and to be able to change, you need this to be in the syntax to access the value. So we need to change. We say star age. So this means now we have the value of age, and we change it now to 300. So now if we go ahead and console.log, or we just go here and we check the value of age right now, go run, you can see that now the age is equal to 100, 300 rather. And this means that we are able to modify this. I know you have a lot of questions, so let's go ahead and do one more example. So let's say we have our struct here. I'm just going to have a struct, and this struct, I'm just going to say type. Let's say this is type person, and this is going to be a struct, and this person has name, which is going to be a string, and has also, let's say, the age. Okay, maybe we just put something else, that maybe we just say experience. Okay, and this experience is int, right? Yeah, as experience, and we want to be able to modify this experience. So we said the first step to modifying. So if we want, for example, to modify, let's say here we create our variable, and we say var student, or you could just say student. Student is equal to, so we can just come here and we say person, and then we can just give a name. Let's say JB, and let's say go ahead and say experience of 5 years. So we have created our variable student. So if we want to modify this, we need to create a pointer variable, because as we have seen, you cannot modify this directly, because this is going to create a copy, and we change the copy, which will not modify the original variable. So to be able to change this original variable, we need to create a pointer variable. So we can just come and say, for example, to create a pointer variable, I can just say maybe I can just say my student pointer variable, which is going to be equal to, and you simply say and of student, like this. Okay, so this now, if you look at its type, you can see it is star person, meaning that it is actually referencing the student. Okay, and by the way, this process of doing this is what we normally call differencing. We're just going to look at it in a second. So if we want to change this, and I say modify experience, just come here and I say, instead of modify age, and I say modify experience. Remember, this is going to be a func like this. So in this case here, we're just going to pass in the person, right? Just going to pass in the, let's say, the person, and this is the star person, because the type of a pointer variable, it is star the original variable, like that. Then in here we just need to change the age. So in this case, if we are having a struct, it is even more easy, because in this case we can just say that person dot experience, and then we give it a new thing, let's say 10, like this. For it, you actually don't need to do this like this if it is a struct. Okay, so if we just go back here on my pointer variable, I can call the modify experience, and then we can just go ahead and pass in the my student pointer variable. Remember, you need to pass in this. Okay, I think for the struct, let me see here, cannot use this. For the struct, let me just go actually pass in this save, and let me just go ahead and, so what I just want to print out here, I'm just going to say experience. So I'm just going to say XP. And here I'm just going to say so we have the student variable. Actually, I just want to go ahead and print out the student. Okay, I'm just going to say print out the student dot XP, like this. So if I go ahead and run this, run go, so you can see that the XP is actually 10. So for the structs, the life is even more easier. So the first step, we have our original variable. In the second step, we created a pointer variable that points to the address of the student. Now here we just simply pass in the my pointer variable, and in this one, what you have to remember is that you need to specify that you are pointing to a struct, and then we can just go and modify any value within this struct. We are going to see this concept is going to be used a lot. So the second thing why we need to use these pointers is that in the when you just like having big structs the way you see there, a big struct can hold a variable of, let's say, 5 KBs. Let's say you have a memory space of 5 KBs in a particular variable, which is a struct. So this is like a variable. So every time you want to modify and you don't use address, you don't use pointers, you are going to make a copy of this. So you just go ahead and make this, make this, make this, and you're going to find that in total you have about 20 KBs if you do 3 modifications. Okay, and this is more memory consuming. Okay, so the more we do or pass in big structs, you can imagine data from API where you have like tons and tons of data. So you can find that you are actually using a lot of memory, because every time you do to manipulate, you end up creating a duplicate copy. And to see how efficient it is to use a pointer, so every time you use a pointer variable, I'm just going to call this a p variable. Every time you use a pointer variable, instead of making 5 KBs, it is always 8 bytes. Okay, it is always 8 bytes, whether big or small. It is going to make only 8 bytes, which is very, very insignificant. So using pointers makes Golang more efficient in handling all its tasks. Okay, so that's like more about the pointers. You can just go ahead and read more about them. I just added a lot of examples here and explaining. For example, the process of difference operator. We have the address of operator, this ampersand, and this gives us the memory address as we saw in the examples. And then we have the difference operator, which has access to the value at that address. And if you have this, if you go ahead and print this, you get access to this value. And through this, you can now go ahead and modify this value. We have done a lot of examples in that case. Okay. We have also the struct here. You can see we have this person, and then you can just go ahead and create this person. And then birthday copy, you can see we have the birthday copy and we are passing in person. Okay. And in this birthday copy, you pass in the P, and then you are changing here the age. And if you go ahead and console, you set, you get the new value. So I also put here when to use pointers. You can see for large structs, you avoid copying large amounts of data and duplicating them, which is more memory exhausting. So that's more about the pointers. I just want us to move to actually JSON handling. So we have here another concept, which is actually JSON handling. So you know very well when you are dealing with APIs, one thing that you need to deal with gracefully is going to be the JSON. More especially, we have two scenarios. So let's say a scenario whereby we are sending data to an external API. So you see that in most of the cases, I'm just going to actually copy, I think, all this code. Okay, I just want to move all this code. Maybe just to move all this code to this statements dot something. I'm just also going to get this. Okay, so you go back here. We have this. So I'm just going to look at JSON handling. So as I've said, we have two scenarios. Okay, so we have two scenarios. The first scenario is when you are dealing with external APIs, whereby the data you need to send is supposed to be in JSON format. Okay, let's say you are handling with an external API like payments API, or like any API you are consuming, a third-party API. You are going to find that it just needs data to be in the JSON format. Okay. Or we are also getting data from an external API, getting it into our app. Okay, so let me just put these two scenarios. We are sending JSON data to maybe to an external API to an external API. And then here we also have a scenario of when we are receiving data from an external API. So when we are sending data from an external API, remember the always the things we have here. This, I'm just going to copy this actually, and I'm just going to put it this side, like so. So I'm just going to go here and I create a new struct. Let's say we have a product. So I'm just going to say type, and I'm just going to create a product, and it's going to be a struct. And let's say we have a product which has an ID, which is going to be an int, and then we have also the product, the name, which is going to be a string, like this. So we have our product, which is of this type. So we have an external API endpoint which expects us to have this data in JSON. Okay, so the problem we have is that this is not a JSON, right? You can see it as capital ID, capital name. So clearly this is not a JSON. So in JSON handling, the first scenario we have is when we want to change a struct into a JSON. So the first case is converting a struct into JSON. And you just convert, if you want to convert this, so that you can just actually send this to an external API. So in that case, we use a function which we call Marshal. Okay, we use this function called Marshal. Just want you to record this. It is called Marshal, and we use JSON encoding to be able to access this. So how would we do that? Let's first have our data. So I'm just going to go here and create a new product based on this struct. So I can just say maybe actually like var product, and then I just say this of course is of type product, and this is going to be equal to product, and then in here you can just come and I say for example we have the ID, right? So you just have like ID, which is going to be of ID of 1. Okay, and then here I'm just going to have the name, and then just going to have name of maybe, let's see, iPhone 16 Pro Max. Okay, just put a comma here. So I have my variable called product. If I go ahead and I say fmt dot print, and I just go ahead and I print the product, you see that this clearly, if I just go ahead and open my terminal, I can just go here and let's go back to, maybe we just actually use the new one. So you can just say go run main.go like this, and you see that clearly this is not a JSON. This is a struct. So want to convert this into JSON, preparing it maybe to sending it on an external API. So what I want is to get this. So in the steps into converting this, we're just going to go here and use this JSON Marshal. So we just come here and we just say just going to have two variables. So we're just going to have the data and the error, and this comes from JSON dot. So you just get this JSON from JSON encoding, or encoding JSON, sorry, encoding JSON dot, and now we just do Marshal just like this. And if you look at the what the Marshal takes in here, okay, if you look at what the Marshal takes in here, it takes in the byte. So you can just go ahead and pass in the whatever we want to convert. In this case, I'm just going to pass in the product just like this. Okay, I'm just going to go ahead and pass in the product, and we get back the data that has been converted, okay, which is actually in a format of bytes price. Just going to talk about the bytes price before you get surprises. And then we have also the error. So if I just go here and I just do if error is not equal to nil, so we have just check this. If error is equal not nil, we can just go ahead and just say fmt dot print line, and we can just say, for example, error, okay, while converting to JSON, while converting while converting to JSON. Okay, and then of course we return. Now down here we actually now have this data. So to give you actually a surprise, I'm just going to go ahead and print out the data. So you might actually expect that this one is going to be the JSON, but it might be surprising to find out that what is going to print out has nothing to do with the JSON. So you can see it has printed out a splice. So this is what they call a byte splice. So a byte splice is just like a representation of a JSON in terms of bytes. Okay, in terms of bytes. I don't know how I can explain more about that. You can just go ahead and you say go byte splice. Okay, you can just like go ahead and search about this. In Go, byte splice generally refers to operations involving byte splices, which are dynamically sized sequence of bytes, sizing byte, blah blah. But you can just go ahead and read about this. But this is what they call a byte splice. So whatever you are doing with Marshal, you're going to be actually, this does not return the actual JSON we expect. It returns a byte splice. So the byte splice is actually just an intermediate thing. We can convert this into a string to give us the actual JSON. So if wanted to get the actual JSON data, we'll just come and say, actually, just do string and then convert this byte splice into a string. This converts it into a JSON. So if we go ahead and run again, so you can see it actually converts it into JSON. The problem we have is that we still have capital ID and the capital name. Okay, so this is not good, because in most cases in the JSON they're expecting their side, these keys are actually in the small letters. It is JSON, but these keys are not good. So to be able to solve that problem, you have to come to this original one here, and you have to map how this is going to look like when we convert it into JSON. So I'm just going to put this backticks. You specify backticks, and you say that this in JSON, I want this to become actually an ID, just like this, small like this. And then for this, I'm also going to use the same backticks, and I say in JSON, I want this to actually be name. So this maps, these are called JSON tags. These tags here, they map how your struct is going to be converted into a JSON. So you need to actually pass in these so that you actually see how these are going to be converted in JSON. So if we run again, we expect now to see a fully JSON. So if you just go here, you can see now we have a JSON with the ID, and we also have this name. Okay, so this is how you convert a struct into JSON. So let's do in vice versa. If we want to actually get the JSON, okay, in this case we are receiving this JSON from an external API, and we want to convert it into into a struct. So in the second case we have here, let me just put 2 here. In the second case we have converting a JSON, the one we have received from the API, to a struct, into a struct. So to take an example, we can just go to an API. In this case, I'm just going to use, you can just go to mockapi.io and just go ahead and create an account, and then you can just go ahead and mock your data. So I have this example endpoint that returns a list of products. Okay, a list of products. So I just want to go ahead and copy just only one example like this. So this is my JSON data. I'm just going to go ahead and create my JSON data. So I'm just going to say var JSON data. We could actually just like simply just say JSON data, and then we just say is equal to, I'm just going to go ahead and put backticks, and then I paste in this. So clearly this is JSON data, right? If you look at this, this is JSON data. So we would want to convert this JSON data we have received from an external API, want to convert this back into a struct. So what are the steps that we are going to take to actually do that? So in the first place, you have to create the struct. So just go ahead and create the struct, okay, and map it to our required, or to our JSON, okay, to our incoming JSON. Maybe we just call this to our incoming JSON. So you need to go ahead and create the struct, okay, how it is going to look like. Let's call this one an API product. So I'm just going to come here and create a type. I'm just going to say this is going to be API product, just like this, and it's going to be a struct, and we start giving. So if you look at this, we have, for example, an ID, and if you look at the ID here, this is a string. But if you think about it, this looks like it is just like a number, but which is in a string. So just going to talk about this. But I'm just going to say here I have an ID, which is a string. Okay, according to this, okay, this is a string. If you want the difference where we have this, you can see this is in quotes, but one is not having quotes around. This is the actual number, right? And this is a string. So wherever you have the quotes around, that's a string. So we're going to see that this is actually a string. Then the second one, we have name, price, and created at. So we have the name, and name is also a string, and then we have a price. Okay, so according to what we have, data we have, this is also a string. Okay, this is also a string, and then the created at, created at is also a string. So but you can say that in this case, I want my price to be a float. So what I would do is I'll just come here and say this, I want this to be a float 64, and maybe even my ID, I want it to be for instance, just like leave it like a string like this, a case in point. And if you look at the created at that we have here, this is a timestamp. Okay, so for the time, actually just going to be using like the inbuilt in the time package. So you can just go just say here the time. So you can say this is going to be time, and this is imported from time, and you can say dot time. So this is the type of this, and you can say like time. The time is also actually a type. So I just done this, created my my struct. The second thing, I have to map it to the incoming JSON. What that means is that we need to go and also add the tags. So I'm just going to come here and say this is actually in JSON. Okay, this is actually coming as a small ID like this. You could find even this is called a user ID. You need to simply map from what is actually incoming here. Okay, if it is coming as a user ID, but for you want to name it as an ID, it is okay. You need to specify the incoming key here, In this case, it's just like an ID. Then the question is, one thing that if you want to see what's going to happen, if the string here is the same as the string here, then you are good to go. You don't need to specify anything else. You simply just leave it like this. So the same thing as JSON. I know you have not understood that, but I'm just going to repeat it. The JSON here is going to be a name. Now let's look at the JSON for price. So I'm just going to say JSON. And here I'm just going to have price. Now look at this. The price we have here is a float. But here we have a price as a string. Okay? We have a price as a string. So what we need to do, we need to actually specify that the incoming price is actually a string. Just like this. So what this is going to do is going to actually try to convert this into a float when we are converting the JSON. So you need to make sure that if what you are passing in here does not match, let's say here you have an incoming as a number, but you want as a string, you need to specify, for example, that this is coming as an integer. So you can just say, like, this is coming as an integer. What this means is that what is incoming is a name in the form of an integer, but you want to convert it into a string. If you don't specify, it means that the incoming name is also in a string format. Similarly to this here, JSON, and then just going to say this is created at, just like this. And the time.time is actually in this format here, so you don't need to convert anything. The only thing we just need to specify is the key. So that is step number 1, actually just going and create a struct and map it to our incoming JSON. Step number 2, we need to use the to create an empty object that is going to store the converted struct, because what we aim is we need to convert this into a struct, right? So just going to create an empty struct by just simply saying that value, I'm just going to call this API product, which is of type API product, just like this. Remember, this simply creates an empty. If you just go ahead and console.list, this just creates an empty object. So we can just come and now use something. So just going to say error, and this, what we do here, returns error. I'm just going to say error is equal to, so just going to say JSON dot UnMarshal. So we have another function called UnMarshal, and you can also just see that it takes in this. I'm just going to go ahead and pass in my whatever I want to convert, which is in this case the JSON, this JSON data. Okay, so I'm just going to say here JSON data, like this. Now this, whatever you pass in here, need to be actually converted into the byte array. So you can see the bytes price needs to be of whatever you pass in here, you have to go ahead and convert that. Sorry. And then here we pass in this API product, and we just don't pass in just the API product like this. API like this. We actually pass in the address so that it is actually getting that. So if you look at this, it's saying no new, here is saying no new variable on left side. So what we could do is actually just do this. We could even just like remove this, and we just simply do JSON.UnMarshal, and then we pass in this, and the API product, remember, if you pass in the address, is going to go ahead and modify the values in here. So if I just go ahead and run, or just go ahead and say fmt dot print like this, I just want to go ahead and print the API product like this. Let's go to the terminal. Okay, so if you just look at the terminal, you're going to see that we have this the ID, we have the fish, we have the price, and then we have the timestamp. Okay, so that means that our actually converting into a struct, it actually did go work. Okay, so this is how we convert a struct into an incoming JSON. So we're just going to make it interesting by actually doing a small project. We're going to actually use this API. Okay, just going to go ahead and see how we're going to use this API. Instead, now we receive an array of products, and then also we can also map, also send an ID here. If you look at our products we have, from this we have 10. I will just go ahead and reduce them so that we can just look at it. Okay, so let's talk about our project that we are going to actually work on, a small simple project. I'm just going to simply go ahead and close this one. I'm just going to go to the same folder here, which is Golang day 2. So we always have a project at end of every fundamentals. I'm just going to say day 2 and just going to say project, just like this. Okay, so I'm just going to go ahead and open this still in VS Code, just like that. I'm just going to go ahead and create main.go like this, and then you're just going to create, of course, package. Just going to say create package main, and let's say func main, just like this. Now what do we want to do actually? So we just want to do two things. Want to do a get request from an external API. So you're just going to look at data fetching from, so I'm just going to say here handling external APIs, just like this. So just going to look at making a get request and also making a post request. So starting with a get request. So let's say we have our endpoint, this. So we already have our endpoint. As I've said, you can just come here and create a new endpoint. Let's create actually just like a new endpoint. Actually, why not? Just going to go back to the projects here. I can just click and I click on a new endpoint, I think. Yeah, you can just like add it as a new one. Oh, you have reached, you only have I think you can only create one project at a time. Okay, so that means I can delete this. Let me just go ahead and delete this and create a new one. So I'm just going to go here and create, and I'm just going to create this and call it the contacts. Okay, I'm just going to create contacts, API prefix, add API prefix to all endpoints in this project. So you could just come and say, for example, API like this, and this, not AP1, API like this. I just want to prefix them with API products like that. So we have the contacts. So this is now, if you go to this endpoint, okay, actually we would have added in a new resource, as simple as that. You don't need to actually create a new project. In one project you can add very many resources. So if you just go to this endpoint, if I click on this, just click on this. Oh, okay, we don't have any data. Let me first actually go ahead and remove this. Okay, go back to in here. Let me just go ahead and generate some things. New resource. Oh, okay, let's first create a schema, because we actually haven't added what is in the contact. Did I just create my project as contacts? Can I rename this? Edit. Oh, not clone. I just want to edit. I don't want just not call this products contacts. I just want to call this maybe, you know, let me just call this is hub. Okay, this makes sense. Under this is hub, now we can create a new resource which is called contacts, and we can just say this is going to have an ID, and you can just like go to here. Okay, so the ID here, and you can see you can't change this, it is object ID. And then we have created art, we have name, avatar. I think this is okay. I'm just going to leave it just like this. Okay, I'm just going to go ahead. You can just like add in more, for example, name. Let's just like add in like email and faker. Let's select this as email, I guess. Internet.email, I don't know. And then for date, recent, then name, full name, and then the avatar. I think that's the best we can get. So just like leave it like this, and let's go ahead and create. So we have created and we have 0 contacts. We can just like go here and use this. You can just like move it to wherever you want, and like this you can create like full contacts. So if we leave it like this, we don't have any contacts. Let's go ahead and go visit this. So you can see this has an empty array. So if I copy this, I don't know why did I just like call my endpoint contacts. Can this be editable? Let's see. Or you can just like edit the name of the resource, right? Okay, anyways, never mind. I'm just going to use that this contacts. So when you just go and copy this, let's take into our postman or HTTP here. So it means I can just go ahead and let me first go in the draft here, maybe. Let's say go and let's say this. And if I just go ahead and send this as a GET request, you can see we get back an empty array. I'm just going to go ahead and in this, I'm just going to say, for example, this is GET contacts. Let me change this. Rename. I'm just going to say GET contacts. Save. And in the second one, I'm just going to actually have the post one. Let me move it here. Okay. I'm just going to say call this create contact. Save. So just like actually add this same, and let's try to actually add in this. So for the ID, in that case, we don't need to pass it in, right? We don't need to pass in any ID. If you look at our schema, let me just actually generate like only 10 like this. So we have 10. If I go back here, actually yes, just text with our API. If I go to get, okay, send. So you see we have actually 5. So you can just go ahead and copy this. Copy this. And let's go to create contact. And I'm just going to paste this here. Let's have this. I'm just going to beautify this. So we have ID. I don't know if I remove the ID if it will work. So I'm just going to go ahead and remove the ID. So we have the avatar. Then we have the name. I'm just going to change this name to Muke John Baptist so that we can look at that. And then the created art. I don't know if This also needs to be supplied. Let me just first remove it. Okay, and this is a post request. I'm just going to send. Yeah, so you can see I have the ID created, I have the avatar, and the name is here. Okay, we left the email the same, which has no problem. Okay, so we now test that if we send this, we actually get back what we created. So we have the read. We can just go ahead and get here. On the get all these resources, and I just want to look at the my name. You can see the name is here. So now we want to do this in our API. First, we need to get all these. Items in our app. So the get request. Let me first go ahead and first get the URL. So this is actually the API endpoint. So I will just go back here and I will just say var URL, which is going to be I think a string is equal to this. Okay, use double quotes. So this is our URL. We're just going to make all our endpoints in this. So I would want just create a function called fetch fetch products. Fetch, or we could just say fetch products. Okay, and this would take in maybe the URL. Okay, would take in the URL, which is a string, and this would return a list of products. So would have a list of get contacts. I don't know why I'm just renaming it products. Get fetch contacts. So this would return a list of all the contacts, right? Let's create one contact. So one contact looks like this. So I'm just going to go here and create a struct. So just say type. I'm just going to call this as a contact, which is a struct, just like this. And I'm just going to paste in this. So first we need the ID. So just going to say ID. In this case, I'm just going to say the ID is going to be int. Okay, and then here just going to put the in JSON. Okay, this is an ID. Just like this, but it comes as a string. Okay, just like this. So it will be converted into a number. Then the second one is going to be name. So the name is a string, and then we can just like put the JSON here. So in JSON, this is going to be name according to here. Then we have the email. So we're just going to say here we have email, which is also a string, and then in JSON it's going to be still called email. And last but not least, we have the avatar. Okay, we have now in this I can just actually name it as image to show you that we can name it as image, and then we said in JSON actually this is coming as avatar, just like this. You get, so this is coming as avatar, and so say string, and lastly, which is going to be the created at this is going to be time dot actually time, just like this, and then in JSON this is simply created at just like this. So this is our first step. Of course, make sure that you get time, just like this. So I'm just going to go here in the fetch, in our fetching the contacts. This is going to return. So this is going to return either error. I'm just going to do this. We are either going to return the products, which is going to be an array of actually contact, or error. So there can be error, just like this, just like that. So we just start by going ahead and we fetch. So to make a fetch request, so make a fetch request, we actually just going to say we get two things. So just going to have a response with an error from HTTP. So here we call it HTTP, and this HTTP comes from the net HTTP package. So just going to say HTTP dot, and just going to use the get on the HTTP. So just going to say dot get like this, and then here you pass in, actually we take in the URL that we have passed in like this. So you can see how we get the response and then we get the error. So you can just first go ahead and just actually do if error is not equal to nil. Okay, so just simply just want to go ahead and so in this case, I think I'll just go ahead and return. What would I return actually? Oh, okay, so I'm just going to just do here var. So let me just call var products. We could just return it from that side, or we do it from this side, it doesn't matter. I'm just going to say var contacts, which is going to be of type contact array, actually, like this. So yeah, just going to like an empty array. So this is an empty array. So here I would return the contacts like this, comma. First of all, let's first console.log this before we return. I'm just going to say fmt dot print. We could actually leave the printing outside if you wanted, right? We could just like leave the printing. We could just like simply return this, the error. We don't even print from here. So you just say print, and then here just say errors. So you just say error. I think this is like errors dot new, and then we can just say error while fetching products, error while fetching contacts, like this. Okay, so if error is not equal to this, I'm just going to, so here the error we have here, we can also say, okay, we can just say error in counting. I'm not sure why we have this undeclared. Oh, okay, so this is supposed to be like this. Okay, so now we have this response. So the first thing that we need to do actually from this response is to go ahead and close the connection. So let's go ahead and close the connection. So normally when you create a new variable, like you go ahead and create like var this. When you create this, it is assigned to a memory, and after using this variable on the memory, go garbage collector, so there is something called go garbage collector, will go ahead and free up the memory if you are no longer using this contacts. So this is how it works for all variables. If you create var URL and you no longer use this, okay, if you no longer use this, the garbage collector is going to go ahead and remove this from memory and free up that memory. For the case when you're making HTTP requests, this is not the case. This is a special case whereby the garbage collector cannot actually close or clear this the memory that is assigned to this response. Okay, so we have to free it by ourselves, otherwise you are going to end up actually having a memory leak. You can search about the memory leak. I'm just going to explain about it in a second, but I'm just going to say here that response dot body. Oh, okay, we start with this. We start by saying defer, and then we say response dot body dot close, just like this. So what this does is it closes this connection with the external server, because when you just go ahead and you see http.get like this, you're actually connected with an external server streaming data from that server to here in the memory. So you need to close this connection to avoid memory leak. And what is memory leak? As you hear the statement suggests, leaking. Leaking, just like the way you forget to close the tab. Okay, so after you have fetched the data and the data came through, you need to actually close the connection to avoid consuming memory all the time, like continuous consumption of memory. If you don't close this, this is going to continue actually connected to the external server, and this can cause really a lot of problems and slowing down your machine. So we have to close this, and then we can just say if response dot status code is not equal to 100 or is not equal to 200, then we can just go ahead and return also like this, and you can just say error with status code. Maybe just going to say error with status code. We could just say error. We're just going to leave it just like this, error while fetching contacts, and like that. So if we pass at this step now, we're just going to go ahead and we can read the body. Okay, we can read the body from the response. So here we also have two things. I'm just going to say here we actually have the body plus the error, which is going to be also IO. So here just going to use IO dot read or like this, and I'm just going to pass in the body, the response dot body. Now I know if you are coming from JavaScript side, you're wondering why are we having a lot of code to do the fetching. It was the same question I asked at first. Why are we having a lot of things for fetching? But that's how it works. We are using actually we are using the raw Go package. Okay, this is sometimes how it is. If you have tried to do it like fetch data in Node.js or in a PHP or somewhere, you know, you always have like some more code than expected. So here we have read. We can just go ahead and read the body, and the reason why we use io.read, or if you just read this one, read all from R until, just want to talk about this, the res.body here. So the body represents the response body. The response body is streamed on demand as the body feed is read. So this is a streamable content. As we are getting it from the API, this is being streamed. And this io.read all is the one which puts it in one container so that we can save it in a variable like this. So we just get this, and now we are saving it in this variable. If we get error, of course, I'm just going to go here and check like this. If error is not equal to nil, I'm just going to just come do this. And then down here we have the body, right? So this is why we use our Marshal thing. In this case, are we doing a Marshal or an UnMarshal? We are trying to get back getting data from the API. That means we are actually getting it from JSON to struct. Therefore, we're just going to use so here convert JSON to struct. We know how this is done, so we can just actually just say JSON dot UnMarshal like this, and here we can just pass in the body, comma, and then we pass in the contacts like this. Okay, we can pass in the contacts, and then afterwards here we can actually go ahead and return let's return the contacts like this. Okay, of course the comma near, like if there is no any errors. So this one is going to go ahead and get this data which is in the body and feed it in the contacts which we actually created up here. Okay, so this should get us the contacts. So I'm just going to go ahead and use this fetch contacts in here. So I will expect to get two things. I expect to get our data, and the error is going to be equal to fetch contacts, and let's pass in the URL, and we're just going to say if error is not equal to near, then we can just go ahead and also let's copy this, do this, and in this case I'm just going to simply actually before the return, let's go ahead and print this fmt.print. I'm just going to say sorry, I'm just going to say error here, or you could just even just print out the error just like this, and let's go ahead and return. Okay, and then here I'm just going to go ahead and map. So I'm just going to say for, just going to do the for, and I'm just going to do a for range, and here I'm just going to say we have a single contact like this, and then here we have the what we call it data, and then inside here I just want to format this. So I'm just going to say fmt let's say fmt dot, I just want to print format, so just say print f, and let's pass in how we want this to look like. I'm just going to pass in the, just going to have the ID, so just have space %d dot space, then I'll put the name, so %s, then put space this, and then I will put the we have ID, name, let's say email, so here just going to say %s, and let's put space and the %s, so yes, that is the, after the email we can put the ID, and we can just even after put the date. I'm just going to leave out the date, so I'm just going to put comma, and in the first point is we have the ID, so I'm just going to say contact dot ID, and the second one is the name, it's going to be contact dot name, and then you're just going to have contact dot email. Do we have another one? So we have one last one, which is going to be the image, contact dot image like this. Okay, so now I'm just going to just say here that print fmt dot print I'm just going to print that they fetched products, contacts. I don't know why I like products all the time. Contacts like this. So if we just go ahead and now, if everything is good, we should just see the fetched contacts. Let me just go to this here, open the terminal. I'm just going to say go run main.go. One more thing, I'm just going to add in here. Here is just add slash new line. Okay, like this to make sure we have the new line. Okay, just run this and hopefully we get the data back. Okay, so we have here the fetched contacts. The number one is Jenny with this email. I just want to look for my name. So you can see 11 here. We have my name here. Okay, which is really cool. Okay, so we have fetched all the products from the API. Okay, so we just now want to actually create a new product. Create a new contact. So I'm just going to say create func create contact. Okay, just going to say create contact, and in this case just going to also have the same thing. We could pass in the new contact we want to create, or we can just say create it from inside. But here we're just going to do actually a post request. Okay, so we can first of all prepare our post that we want to go ahead and do that. Then we convert it into a JSON. Then we send it to our API. So what I can just do is let's go ahead. Let's first create the post. So here we just say, for example, var new contact. So this would be a new contact, right? So the new contact would be just going to say contact. Okay, and let's go ahead and copy some details. So we have the name. So remember, when you are creating, we don't need so many. We need a few things. We need, if we go to the create here part of things, we need only these ones. We need the name, avatar, and the email, right? So we need the just going to say the name. Okay, let's just call this one this is hub user, so that we can just ignore that. And then we have, so we don't need to create an ID, just going to add the email, which is going to be this is hub.info@gmail.com. And then lastly, we just need to create the image, which in this case, I'm just going to go ahead and copy one image from this same very API. Let's copy this. The image doesn't matter in this case. I'm just going to copy this. So the only three things we need actually are these ones to be able, the date and the ID, they will be auto created. So this is our struct data. So we need to convert this into, so convert. Let's convert it into JSON. Convert it into JSON. This is why we use the Marshal thing, right? So we have, for example, the data, and then the error. Of course, even this one is not taking anything, but this can actually return This should return what? It should return actually the contact. Okay, it should return the contact and the error. The created contact and the error. So here you're just going to convert, and you're just going to have this, which is going to be JSON.Marshal. And this will just like take in now our struct, which is going to be the new contact. Sorry, the new contact, like this. And then we can just go ahead and do the if statement. Just going to copy in here, this case. I'm just going to do this. Okay. I'm not sure if we should also return the created the created one, because the created one, it should be a JSON, which is in this case a string, maybe. I'm just going to say if there is error, we're just going to return this empty, and then you create error while converting to JSON, just like this. And if there is no error, that means we get the byte stuff here. So we can just now say payload. I'm just going to call this payload. So I'm just going to say payload is equal to, so I'm just going to say is equal to string of data, like this. So remember, this one converts it into a string here. And now what I just want to do is what? After now we have this, can we actually send this to an API? So send the post request. So just going to have also the I think the response with error from http http.post, and this takes in three things. Okay, it takes in first the URL, which would have thought to pass in the URL here, which is a string. And let's say, so here just going to pass in the URL, then the type of data that we are sending. So the type of data that we are sending, which is going to be application JSON, like this, the type. And then the actual data that we are sending, which is actually I think it is byte dot new buffer, something like this, new buffer of payload. If I'm not mistaken, let me just confirm from the documentation. So we have the one for post, have the new post converted to JSON, and then we make a pull request. So it is bytes dot new, so it's bytes dot new. So this is bytes. Okay. Are you supposed to put a comma here? I'm not sure. What is the error here? Missing comma. Really? Okay, then we really need to get these bytes. And the payload is a cannot use payload variable of type string as byte value. So this one, I think it needs let's just look at it. If you look at just text in the they just, okay, we don't need to stringify it actually. So this one is expecting the actually the data. We don't need to stringify. It expects this actual data like this. Okay, so from here we have the response. So we could first come here and we close the connection, also close the connection the way we did it before, and then we can just say differ. Okay, response dot differ response, I think, dot body dot close. Why is it not doing the, we can first get okay, it is a response. I think we can first get this. How comes the error is, oh, okay, I think I have a mistake. So we create here a new this. We're supposed to first actually have the if statement here. If error is not equal to nil, then we're just supposed to go ahead and return error. I'm just going to go here and say error while creating a new contact. Okay, just like this. And for this dot close, so response dot body dot close, like that. And now we have this response that we have here. I think we can read it. Let me just see what you can do with that. So you have the response dot status. I don't know what this is. If you want to read this created thing, I'd want to get that created thing. How do you read that? We could just say return response. Do we need to read it using the, I'm not sure if you're supposed to read using the IO or response dot body for that matter. It looks like you need to read it or something, like if you look at this. Okay, let me just try to read it and I say const. We just say like created. Let's say created item, and then I put like comma error, and we are like IO the read, and then you put in response to body like this, and then you could also do this. And this created item, and then let me just go here and just say return. Okay, I just want to return the string of created item, and then comma near, like this. So like this string of created item should be our item like that was created. So let me just go ahead and get this. I might actually just go ahead and let's first go ahead and do this, create item or create contact like this. We pass in the URL and this should just like give us the created contact, or we could just like create the new contact with error is equal to this, and then we can just say if error is not equal to nil, then we could just go ahead and print out that error. And then here we could just say also fmt the new fmt.print. I could just like print the new contact. Okay, I don't know what's going to happen, but let's go ahead and run this. Just going to clear and just go ahead and run. Okay, so if you look at this, we go run and we just get back a JSON actually with created at, name, avatar, and email with the ID of Torov. And if you just go to fetch, you said we actually have this the sub user. If I also confirm by going in the get contacts here, send, and you see we have the Torov. If you also confirm by going to your Mocha API, just refresh, and you see you have 12 contacts. Okay, you have 12 contacts. Yep, so this is what has been into this episode. I hope that you liked everything. Okay, I hope that you liked everything. So thank you so much for watching. I will see you in the next one.